give us a little buzz thing, and it tells us it's going to be between minute 5 and minute 25 still, except that they tell us that it's a lot more likely that it's going to be closer to minute 25 than it is minute 5, and that the probability distribution is this triangle there, which is a nice right triangle there. So this is x, and this is p of x. Okay, so the first thing we want to do is think about how tall that has to be in order for this thing to work out. Remember that x is the list of possible values. Possible values. That's what x is. So we want to know the probability that x is between 5 and 7, that x lands between 20 and 25, right? That's what the questions are going to look like. The picture, that triangle, is simply describing for you the probability distribution that's going to take shape. Okay, so we know that we're going to need that the area of any triangle, is equal to 1/2 times the base of the triangle times the height of the triangle. 1/2 base times height. That's always the area of any triangle. And so in particular in this case, if I want to make this work out and be a proper probability distribution, I need the area of this triangle to be equal to, it's got to be 1, right? The area has to be 1 for it to be a proper probability distribution. So 1 must be equal to 1/2 times the base. Now in this case, the base is this, which is 20, or it's 25 minus 5, times the height, which is what we're after. So simplify this. This is 1 equals to 1/2 times 20 times the height, which is 1 equals to 10 times the height. And so we divide both sides by 10, and we get 1/10 is equal to the height. So in this triangle, I need that height to be equal to 1/10 in order for this whole thing to work out as a proper probability distribution. Good? Questions, comments, issues? Questions, comments, issues? No? 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 Okay, so now that we have a proper probability distribution, we can answer questions such as, what's the probability that we get a value between, what did we do before, 8 and 10? I think, yeah, probability that it lands between 8 and 10. So find the probability that the result is greater than 8 but less than 10. Well, by my picture, I can tell that that's going to be the probability that it lands either there or there. And okay, so this is probably not a there or there. So it's going to be that or that. I want to find out those guys right there. Okay, so I want this area right in here. If I can find that area right in there, that'll give me that answer. Okay, so in order to find that area, I need to find the value of this and this point, right? If I can find the value of those 2 points, I'll be able to find what I need to be able to find that area. And so in order to find the value of those 2 points, I'm going to have to find the equation of this line. Now this line goes on forever. It's a line that extends that way, going that way, and it extends this way, going this way. So the line goes on forever, even though we only need it for this little segment of the valid for this word problem. So I need to find the equation of this line right there, and that's what we're after now. So must find the equation of this line. Okay, so to find the equation of any line, we need to use the equation y equals mx plus b. Y equals mx plus b. So we got to find the slope of the line, and then we got to find the y-intercept. So the slope of the line, and then the y-intercept, which is right over here. That guy. And well, at least we have a couple of points on that line, right? We need a couple of points to be able to find the equation of a line. what is one point we have? We have 5, 0. That's that point right there. And we also have this point up here, which is 25, 0.10. Right? 1 over 10 is 10%. Good? Good? Okay, so to find the equation of that line, first I have to find the slope. M equals to y sub 2 minus y sub 1 over x sub 2, x sub 1. Okay, so we need some points. So the 2 points that we're working with are 25, 0.10 and 5, 0. So here is my x1, y1. Here is my x2, y2. And so m is going to be equal to 0 minus 0.10 divided by 5 minus 25, which is negative 0.10 divided by negative 20, which equals to positive 0.005. I think. We good? Okay, so now that I have the slope, now I got to find the y-intercept. So I'm going to go back to my equation of y equals to mx plus b, but now I have the m, 0.005x plus b. So I already have the m. Now I got to find b, and I'm going to use one of those points. I can use either one, but this one seems a little easier because I got a 0 in there. So I'm going to use that one. So use point 5, 0. So this is my choice of x, and this is my resulting y. So 0 is the answer when 0.005 is multiplied by 5 plus b. So this is going to be equal to 0 equals to 0.025 plus b, and so negative 0.025 is equal to b. And we have our linear equation now. So this means that y must be equal to 0.005x minus 0.025. That means that that's the equation of this line right over here. So this line right over here, I can put it on here, is y equals to 0.005x minus 0.025. Any questions? Okay, I know it's getting kind of heavy in here. So now that we have this equation, this is an equation where if I input a value of x, it will tell me the resulting value on that line. So I can check it because if I type in x equals to 5, this equation should give me an answer of 0. If I type in a value of x equals to 25, this equation should give me a value of 0.10. So let's check it briefly here. Let's get rid of this. So if x equals to 5, then y equals to 0.005 times 5 minus 0.025. You guys paid for the color class, right? There you go. Alright, so then this is then just going to be equal to 0. So it worked out. When x was 5, we got an answer of 0. And then if x is equal to 25, we're just double checking here that we are getting the results we expect. Keep doing this. This is 25 minus 0.025. So now calculate that out, and we should get what we want, which is equal to 0.10. Okay, so we typed in 25, we got an answer of 10. Okay, now we're finally ready to go back and answer what we really wanted. We want to know the height of these 2 points so that we can figure out the area of that little red spot there, that red region. Okay, any questions before I leave anybody behind? Good? Good. Good. Okay, let's go ahead and use our equation then to find those 2 points. So these were just to verify that our line was working out. But now let's do the ones we need. If x is equal to 8, let's find out what the resulting value on that line is. So it's going to be 0.005 times 8 minus 0.025. And that should be equal to 0.015. Check my math there. If x equals to 10, then y is equal to 0.005 times 10 minus 0.025, and this should be 0.025. Good? Any questions? Is that working out? Can't rely on me to do arithmetic. Okay, so we found that this height right here, excuse me, going by, sorry. This guy is 0.015, and this guy is 0.025. Any questions? Good, good, good. Okay, so now finally I'm ready to go back and answer this question after all that work. So I'm just going to redraw just this part here. I'm like zoom in on it because it's too messy right now. So I'm going to zoom in on this part right there, and if I did that, I would end up with something that looks like this. I have, this thing like that, and I guess not zoom in, but I'm just going to put in the important parts. So this guy and this guy like that. So here we have 5, here we have 25, here we have 8 and 10, and this guy over here was 0.025, and this guy here is 0.015, and I want to find the area of this region right in there. Right? So that's the part, that red part is the one that will give me the answer. The probability that x lands between 8 and 10 is equal to the picture above it, just like we've done before when we had discrete random variables. The probability that it lands between 6 and 8, okay, well we just add the areas above them. And when we had uniform, then we found that rectangle above it. Well, now we have this. All right, so in order to find that area, what I'm going to do is I'm going to break this up into 2 pieces. I'm going to have this sort of green triangle part above, and I'm going to have this blue rectangle below. Wow. So in order to find the area in red, I'm going to find the area of the blue rectangle and the green triangle, break it up that way, and that shouldn't be too bad. They're both going to have the same base of 2, right? This distance from there to there is 2, and that's the base of both the rectangle and the triangle. And now here, this distance right there, that height is equal to this, so that height is 0.015. And now this guy is a little trickier, right? People often think it's that, but it's not quite that, because that's the height of the entire thing. So if the entire thing is 0.025, then just this guy here must be correct, right? So this is 2.5%, this is 1.5%, then this is just 1%, the height of that guy. And now we have everything we need to find the area of the red, the whole thing. So let's put it together. So finally, the probability that x is greater than 8 but less than 10 is going to be equal to the area of that red region, which is going to be equal to the area of the triangle, the green triangle, plus the area of the blue rectangle. Right? We have to get creative this time. It's not as easy as the uniform distributions one. So now the area of any triangle is equal to 1/2 times its base times its height, plus the area of any rectangle is just equal to base times height. The height of the rectangle is the height of the triangle, so they're not necessarily the same thing. They're two separate little shapes that we have to use. So working with the triangle, the base is going to be 2. It's going to be 10 minus 8. So this is going to be 1/2 times 10 minus 8, which is 2. That's the base. Times the height, and the height was equal to 0.015. Oops, messed up. The height is 0.01. Okay, so that's the height of the triangle, and then the base was just that. And then the rectangle, well, that's just even easier, 10 minus 8 times the height, which was 0.015. Okay, so that'll do it. We can simplify this a little bit. This is 1/2 times 2 times 0.01 plus 2 times 0.015. So this will be equal to 0.01 plus 0.03. So the answer is 0.04. Any questions? Let's do one more. How about if we want to find the probability that x lands between 8 and 20? So if we want to find the probability that lands between 8 and 20, I'm going to redo the whole thing because it's kind of messy now and there's a lot of stuff. We don't need to reinvent the wheel. We still have the original setup. So we have that the minimum value is 5. It goes out to 25. And we want to know the probability that lands between 8 and 20. So now this is the area we're after. That one right there. We know that this height over there was 0.10. This is P of x. This is x. And we want to find that probability right there. We also already know that the equation of this line is y equals to 0.005x minus 0.025. We've already done all that work to find the equation of that line, so we don't have to reinvent it there. So if we want to find the probability that it lands between 8 and 20, so probability that x is greater than 8, but less than 20, remember that this is the same thing as the probability that x is greater than or equal to 8 or less than or equal to 20, right? So whether or not you include the equals or not, doesn't matter. And whether you do it on one side or not the other, doesn't matter. They're all going to give you the same result. Okay? So now there's a slightly different way we could do this. We could do it the same way as we just did. We can break this up into a little triangular region and do triangle plus rectangle, just like we did a second ago. Or we can do something else just a little bit different. But either way, we're going to need those points up there. So I need to figure out that point, and I need to figure out that point. Well, that one we already got. When we evaluated this before at x equals to 8, we got that this was what?
0.015.
The one with 8 was 0.15? Wasn't it the other one?
No, the other one was 0.025. This one is 0.015.
Okay. Good. Okay, so now all we need to do is find this one. So we need to evaluate our function at x equals to 20 so that we can figure out the value of that guy. And it looks like it should be pretty close to 0.10, right? A little bit low, a little bit below that. So if x equals to 20, then y equals to 0.005 times 20 minus 0.025, put a 20 right in there. So this is 10%, yeah, 0.75, yes. Okay, so that means this guy over here, 0.075. Good. Okay, so we can break it up into triangle and rectangle like before. That's perfectly okay. And that should be pretty easy. In fact, let's just do it both ways. So if we break it up, just like before, I know the height of this part is the 0.015. And if the whole thing is 7.5, that means that this part must be 6, 0.06. That they both add up to a height of 0.075. Good. Okay, so if I was doing the whole rectangle and triangle part, then this would be equal to 1/2 for the triangle part, 1/2 times the base, which is equal to 20 minus 8, times the height, which is equal to 0.06, plus 20 minus 8 times 0.015, right? Where this is the area of the triangle, and this is the area of that rectangle. Right? They both have a base of 12. It's going to be 20 minus 8, 12. They both have a base of 12. And then this has a height of 0.015. And this has a height of 0.06. So this is going to be 1/2 times 12. That's going to be 6 times 36. This is going to be 0.36 plus, and this is going to be 12 times 1.5. Is that 20? No. 18?
Yeah.
0.18. So that should be 4654, 0.54%. Any questions? Yeah.
How do you get the 0.06 for the second value?
Oh, okay, so we figured out that this whole thing there is this guy, right? Because we evaluated our equation over there. So this whole thing is 7.5% or 0.075. And I know this part is only 1.5%. So 7.5 minus 1.5 gives us 6. Okay, but the other way that we want to do this thing, perfectly valid, it's just a slightly different way of looking at it, is that instead of breaking it up into rectangle and triangle, what I'm going to do is think about the entire, this entire triangle there, and then think about this little triangle right there, and then subtract the big triangle minus the little one. Okay, so if I can think about this little green triangle in the corner, the big triangle, including both green and red, we can figure that out. And then subtract off the little triangle in the corner, that's the little green triangle, and that should give me the red region as well. Right? So that's another way to think about this. So the probability, that x is greater than 8 but less than 20 is also equal to the probability that x is strictly less than 20, right, all the way out to where it starts, so between 5 and 20. Well, in fact, we can write that as 5 greater than x less than 20, minus the probability that this is 5x less than 8. Right, so between 5 and 20 minus between 5 and 8. So this is the big triangle, including both the green and the red, and this is going to be the triangle of just the little green. Now, x can't be anything below 5 according to our probability, so you don't have to write it this way. You can also just write it as the probability that x is strictly less than 20. It's kind of built into that you know, the smallest it could be is 5. So anything lower than 20 minus the probability that x is anything lower than 8. So either one of those is fine. So the probability, this is both the green and the red. This is going to be 1/2 times the base times the height. The base is going to be 20 minus 5. and the height is going to be the 0.075. This is the big triangle, both green and red. 1/2 times its base times its height, minus the little baby triangle in the corner. That's going to be 1/2 times its base, which is going to be 8 minus 5, times its height, which is going to be equal to 0.015. Okay, so we simplify this. 1/2 times 15 times 0.075 minus 1/2 times 3 times 0.015. I get this is 0.5625. So that's the area of both the green and the red, the big triangle, minus the area of the little green one, 0.0225. 0.5625 minus that. I get the same answer of 0.54. Any questions? Things are starting to get hard, so you should have questions. No? Okay, so let's up this a little bit. How about if we have a slightly different type of distribution, still triangular, but a little bit more complicated because it's not given as a right triangle. So things just get a little more complicated. What if we are told still at that restaurant, really want a seat there, so we have this, but let's say that, let me make this bigger. Let's say that we have let's say we're given this 0 p of x and 0.80. So let's say we're given this as our probability distribution. So this is the value of x. So x can range starting at 0. So they give it a little buzz thing and they say, okay, well here when it buzzes your table's ready. And it could be anywhere between 0 minutes and, well, we don't know what this is, some unknown w value. I don't know how long it's going to take, man. Could be an hour, could be 3 hours, maybe tomorrow, I don't know, just go wait. Right? So we don't know how long that is. Let's figure out how long that has to be. Well, if they told you that this was the probability distribution, and you got some stats background, then you know that if this side of it is 80%, how much is the right side of it? In order for it to be a proper probability distribution, it's got to add up to 1. So I already know, I can conclude that this must be 20% over there. Okay, so now I also need to find a height. I need to know what is this value here that will make that whole thing work out. So that the area inside that triangle is equal to 1 given the values along the horizontal axis. So we can use our formula for the area of a triangle one more time. The area of a triangle is equal to 1/2 base times height. So let's work with this triangle here. So area of triangle is equal to 1/2 times the base times its height. So in the case of this triangle here, let's color it in, I guess. In the case of this red triangle there, the area is told, we are told is equal to 0.08. So we have this equation, 0.80 must be 1/2. Now the base, we know the base is 20 times 20. And then the height is what we're after. Okay, so that's a simple algebra question now. This is equal to 0.80 equals to 10 times the height So then divide both sides by 10 and we get 0.08 is equal to the height. So now we know that this must be 0.08 right in there. That's the number that makes the left triangle in red valid. Good. And now that we know the height, we can find the value of W. W, again, must be a number that makes the area in the right-hand side, the little white triangle on the right-hand side, valid as well. So again, we can use the same formula. The area of triangle is equal to 1/2 times its base times its height. So in this case, this must be 0.20 must be equal to 1/2 times its base. Oh, well, we don't know that. Right? Because I don't know how wide this is going to be, so that's what I'm after. I want to know what the base is going to be. Times its height. Well, the height we already know. That's what we figured out to be 0.08. So this is going to be 0.20 equals to 0.04 times the base. And then if we divide them both, we get 0.20 divided by 0.04 equals to the base. So the base is equal to 5. Okay, so that means that this width has to be 5. This width must be 5. Therefore, W is 25. Questions? Right? The base was just the base of this triangle. The answer isn't 5 for W. The answer must be 20 plus 5 for W. Good, good, good. Okay, so now that we have a proper probability distribution, then we can answer questions such as, what's the probability that the little buzzer goes off at between minute 15 and 24? Find the probability that X goes off between minute 15 and minute 24. This guy's kind of messy right now, so I'm just going to redraw it with less stuff on it. Just the essentials. So we have something that looks like that. Here is 20. We just found out that this is 25. This is 0 over there. And we know this height over here is 0.08. And now what we want to know is the probability that this buzzer will go off between minute 15 and minute 24. So I am after this shape right here. Any questions? Let's do this over. So I want probability that 15 less than x less than 24. Any questions, any questions, any questions, any questions? Okay, so similar to before, we're going to have to find some stuff here. We need to find this height right in there, right? That's important so that I can figure out how to find that. And then I also need to find this guy right over there. So what I'm going to do, my game plan is that once I find that right there, I'm going to be able to break this up into that triangle, and then on this side we'll break it up into these triangles, and we'll have a lot of fun that way. Yeah. Okay? So we'll get back to that, but for now we need to find that point right there, right? I'll refine that in a little bit. So we need to find the equation of this line going this way, and then we also need to find the equation of this line going this way. Okay? So, man, I can't seem to find a good place for this statement. I'm going to erase it again so that I can find the equation of this line going this way. We need to find that equation. And we also need to find this equation, this way, of this line going this way. right? So these two lines, so let's call this line 2, line number 2, and over here we'll call this one line number 1. And I'll restate the statement in a second. But we need to find the equation of line 1 just so that I can find that point right there. And I need to find the equation of line 2 just so that I can find that point right in there. So we're going to have to do y equals mx plus b twice the fun in order to be able to find the 2 points that I want. Okay, so focusing on line 1, or line number 1, we need some ordered pairs. So what are the 2 ordered pairs we have? Well, we have 20 comma 0.08, and we have 0, 0. Okay, that's going to make life a little easier. There's a little bit of good news. 0.08 and 0, 0. That should make that an easy line. So we want to use the equation y equals mx plus b, and then we want to find the slope m is equal to y sub 2 minus y sub 1 over x sub 2 minus x sub 1. So this would be 0 minus 0.08 divided by 0 minus 20. So that's going to be 0.08 divided by 20. So that should be 0.40, I think. Good. And, well, luckily, the y-intercept is going to be 0, right? So, in our equation of y equals mx plus b, I know this is 0. Because the y-intercept is 0. So, y equals to 0.40x is our equation. We don't have to worry about the b. Yeah?
I got 0.00.
Oh. 0, what am I doing? 0, 0, 4. I knew it involved a 4 and a 0, so I was almost right. Good? Any questions? So that's line 1, right? Going over here, I wanted to describe this guy here. This line right there is y equals to 0.004x. 1 down, 1 to go. Now I got to find the green line. So the green line, line number 2, we need some ordered pairs again. And so the ordered pairs that we definitely know for sure on that green line are going to be again the point 20 comma 0.08 and the point 25 comma 0. Right? This point right here, 25 comma 0 and 20 comma 0.08. Okay, so again we need to find the slope. M equals to 0 minus 0.08 divided by 25 minus 20, which is 0.08 negative 0.08 divided by positive 5. And what do we get?
Negative 0.01.
Here, let me put this over here. 0.08 divided by 5. And we get negative 0. What?
0.16.
0.16. Negative 0.6. And it makes sense that the slope is negative, because the line is got a negative slope. Okay? Yeah, question?
Why is 0 minus 0.8 negative there and not there?
Because 0 minus 0.08 is negative. And then,
No.
well, oh, I made them both negative. So, I'm sorry, I was kind of like doing 2 things at once. They're both negative, therefore they both cancel and giving me a positive. Questions? Great, okay, so now we have the slope, now we need the y-intercept. In this case, it's not as easy as before because it's not 0, 0. So I can tell the y-intercept is going to be up here somewhere. It's going to be a number that's bigger than 0.08, right? So much bigger, but relatively speaking, you know, it might be like 0.7 or 0.9 or something. Something up here, positive though, that's what I'm expecting. So I'm going to go over to my y equals mx plus b. And now I have the m, so y equals to negative 0.016 x plus b. And now I need to use one more point in order to find the b value. I'm gonna make some room here, I don't need this anymore. So I have y equals to negative 0.16 x plus b, and I'm gonna use the points 25, 0. I can use any point I want, but why not use a good one? Right? It has 0 on it, so it should be a little easier than the one that doesn't have a 0 on it. So use 25, 0. You can also use the other one if you want to. They'll both give you the same answer. So this is an x, this is a y. So 0 should be the result when negative 0.16, there's an extra 0 in there. 0.16x, 0.16 is multiplied by 25 plus b. Okay, so 0.016 times 25 so it's negative 0.4. So 0 equals to negative 0.40 plus b. So when I move it over, I get a positive 0.40 equals to b. So 40%. So now my line is y equals to negative 0.016 x plus 0.40, and that's the line of this green line. So this line right in here is y equals to negative 0.016 x plus 0.40. Any questions? Almost there. So now that we have both equations, we have this equation and we have that equation, we can use this blue equation here, line 1, to evaluate the point when x equals to 15, so that we can find that point right there. And we can use the green equation to evaluate this equation when x equals to 24. We can find that point right there, and then we'll have everything we need to be able to figure out the area in red. Messy, messy thing. Good. Any questions? Any questions? Any questions? Yeah.
So we use the same coordinates for both equations?
Well, no. This was the same coordinate for both, yes, because it's both on the blue and the green. So we did use this one on both equations, but then for the blue one we use 0, 0 as the other point, and for the green one we use 25, 0 as the other point. So this one was in common, but then they had different points. The other one was a different point. Good. Any other questions? No? No? Okay, so now let's evaluate them. Let's get to the point there. So, if x is equal to 15, then we use the blue line, because it's on that line right there. So it's that point right there. Then we get that y is equal to 0.004 times 15. Give you color. So y is equal to 6? 0.06. Okay, got that. And if x is equal to 24, then y is equal to, now we got to use this equation to determine the point there. So this will be negative 0.016 times 24 plus 0.40. Here's the 24. And what do we get there? 0.784?
I got 0.016.
0.16. Okay. Good. Good. Okay, so that means that on my picture, this height right there, is the 0.06, and on my picture, this height over here is 0.016. Good, 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 good. Good, good, good. Okay, finally, let's get to our question. And I'm gonna redraw it one more time because it's pretty messy again. So now I'm just gonna put in just the parts we need. So again, we're focusing on what's the probability that x lands between 15 and 24. So the same picture, I'm just gonna simplify it just a little bit. We have this kind of thing like this, and we have this guy here at 15. We got this guy here at 24, 25. This guy is 20. So what we're gonna do is we want this whole area here in red. That's what we want. So we're gonna break this up into some pieces here. We're gonna first of all chop this in half, and then we're gonna think about this triangle right there, and then we're gonna break this up, and we're gonna think about that triangle right there. So there'll be an area of that triangle there, I'm gonna call area A, and then there'll be this big rectangle there, that's area B, then area C, then area D. Right? So I gotta find 4 of them separately, add them together, that'll give me the area I'm looking for. Good? Alright, let's fill in some other values we know. We know that this height up there is 0.08. I know that this guy right here is the 0.06. And I know that this guy over here, that guy is 0.016. Okay, so that's all I really need. Okay, so now let's make the statements that we want. So the probability that x is, the probability that we have x is greater than 15 but less than 24 is going to be equal to area A plus area B plus area C plus area D. Right? Find all those 4, add them together, done. Okay, area A. Well, that's a little triangle. I know that's going to be equal to 1/2 base times height. The base of A is going to be equal to 5 units. It's 20 minus 15. The height, that one's a little trickier. The whole thing from the ground all the way to the top is 0.08 or 8%. And I know that from the ground up to there is 0.06. Therefore, the height of the triangle is just going to be the subtraction of the two. Good? So 0.02. All right, so the first triangle is going to be equal to 1/2 times 20 minus 15 times 0.08 minus 0.06. Right? So that's just equal to 1/2 times 5 times 0.02. Right? That's just triangle A. That's just going to be 2 units there, 0.02, 2%, and then the base is 5. And for a triangle, you always multiply times 1/2. Okay, so that's just area A, plus the rectangle, that one's easy. Base, height, that's just going to be 20 minus 15 times its height, which is 0.06. So that's just going to be 5 times 0.06. So this is area B. Area C is another triangle. The base is going to be 24 minus 20, or 4 units. So plus 1/2 times 24 minus 20, or 4 units. And its height, okay, so again, this was 0.08 there. This is 0.016 there. So that means its height is going to be the difference between the two. So it's going to be 0.08 minus 0.016. You know what? I ran out of room here, and it's going to be kind of ugly. So this is going to be equal to 1/2 times 4 times 0.064. Good. And then finally plus D, which is just equal to the base times the height. Plus D, which is equal to 24 minus 20 times 0.016. So this is going to be equal to 4 times 0.016. Okay, so this was A area, I'll just put A. This one was A, this one was B, this one was C, and this one was D. Okay, we set it up, now we can just multiply it all and get an answer. So this is going to be 0.1 times 5 is 0.05, I think. 0.05 plus this guy, which is 0.30, plus this guy, which is going to be 0.128. Is that right? 128?
Yeah.
Okay. And then this guy, which is equal to 6. Is that right? 0.016 times 4. 64. Yeah. 264. Okay. So now we add them all together. And we get 5, 35, 30, 47.8, 53.4, 0.54. Oh, okay. Wow. That shows you how much arithmetic I do. Okay, finally done. The probability that x lands between 15 and 24 in this probability distribution is equal to this whole region there, which we broke up into pieces, so A, B, C, D, and we're able to get it that way. Any questions? Big, long problem. Nasty, nasty, nasty. It doesn't get any worse than this. This is it. This is as bad as it gets. So let's go back now to our slightly easier case where we had a nice right triangle. And let's say we have a right triangle like that. And so it starts off at 0. That's good. That makes life a little easier. And this goes out that way. And let's say we are told the equation of the line that governs that. So let's say that we are told that this line the equation of this line is y equals to 0.125x. Okay. So based on that, can we figure out the value that goes right here that makes this a proper probability distribution? That's the first question here. Find W. Find W to make this a proper probability distribution. Okay. Well, in order for it to be a proper probability distribution, we need the whole area to be equal to 1, right? So what's the equation going to be? It's going to be 1. The area of the triangle must be equal to 1/2 times the base times the height. Okay. Well, the base is going to be this W, right? Because it's starting at 0, so that makes this a little bit easier. From 0 to W, so the base is W. So this would be 1 is equal to 1/2 times that W. And the height, well, I don't know the height, but I know that it's governed by this equation. So it's going to be the height, it's going to be the result of evaluating this at W. So the height will be equal to 0.125 times W. Since it's a nice, easy linear equation, the y-intercept is 0. So we just got to plug in whatever that W is, whatever that answer is in there, and that'll give us the height. Are there any questions about this setup? No? Okay, so now we can solve for W. We can multiply over there. We get 1 equals to 0.0625. No. Yeah. 12.5625. Times W squared. Yes, so that's 1.25 divided by 2.625, okay? So now I can divide both sides by that, and I get 1 divided by 0.0625 is equal to w squared. This side turns out to be 16 equals to w squared. So now I take the square root of both sides, and I know we like to write it the other way around, so I'm just going to go over here and rewrite this as w squared equals to 16. We're just used to having the variable on the left-hand side. So then I take the square root of both sides, and I get that this is equal to plus or minus the square root of 16. Don't forget the plus or minus when we take roots to both sides, an even root. So this means w equals to plus or minus 4, right? So the answer to the equation is plus or minus 4, but according to my picture, I can tell that it's definitely not negative, right? Because I'm starting at a positive number. So I can ignore the negative and say that w must be equal to 4. Right? So I discovered what that value is. So let's go back over here, and I'm just going to rewrite this as 4. This is the w. W is 4. Good? Yeah?
Why did you square W?
Oh, because I have a w from there, and I have a w from there, so together they give me the w squared. W times w. Yeah, question?
How did you get 16?
How did I get 16? Oh, right here. 1 divided by 0.0625 is 16. So I just divided both sides by this decimal. Any other questions? No? No?
Wait, so in order to get 0.0625, you basically multiply 1/2 with that.
0.5, or 1/2 times this gives you this. Other questions? No? 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 Okay, so now we have a proper probability distribution. That means that the area inside the big triangle is 1. I know that the base is going to run between 0 and 4. And I already know the equation that governs that guy right there. So I can find this point now, right? One of the questions now could be, well, what's the height of that triangle? What's this guy right there? Okay, well, I could just evaluate my equation there at 4, and I should know the answer to that. Right? So let's call this, so I just have a question mark, I'll put well, technically it's P of W, right? P of W. Oh, yeah, that's fine. Let's just stick to something like K. Let's find K. So K, the value there, K, is going to be equal to 0.125 times 4. So K equals to 0.05 or 0.50. Okay, so going back over here, this is 0.50 equal to K. Any questions? Questions? Okay, so we got our, oh yeah, question?
I don't know why there's 2 W's. Why is it-
Oh, so going back to, so originally we were given this triangle, and we know that in order for it to be a proper probability distribution, the area of that triangle must be 1, and we know that the equation for the area of a triangle is 1/2 times the base times its height. And so if this is W, we don't know that it was a 4, we just knew it was a W, this W is the base, right? So the base is W. And to find the height, what I have to do is plug in this into the equation. So I get this as the height, right? Whatever W is, once I figure it out, I multiply these two things and that'll be the height. As it turns out, we found out that it was 4. So then when we multiply it, it turns out that this whole thing is 0.5, the height. Good? Right. So we know that 1 times, oh, sorry, not 1. 1 is equal to 1/2 times the base, which turned out to be 4, times the height, which turns out to be 0.50. And yep, that's true. This is equal to 1 equals that. And so this is true. 1/2 times the base times its height equals to 1. Good? Good. Okay, so now let's say that I wanted to find the area trapped between 0 and 1. well, 1's too easy. Let's make it 1.5. Find the probability that x is greater than 0 but less than 1.5. Well, we know that x can't be anything negative according to my distribution. So this is the same thing as just asking the probability that x is less than 1.5. Okay. And so that's going to be this triangle. Let's figure this out. It's going to be a triangle that looks like this. Here's 1.5. Here's 4. I know this guy up here is 0.50. So I'm looking for the area of this little guy right there. And as we've seen many, many times now, I need to find the height. I need to find that value right there. Luckily, they already gave me the equation of this line. This was y equals to 0.125x. So all I have to do is evaluate this function at that point in order to get the value of x, and then I'll be able to find that little blue triangle. Does that make sense? Okay, so this is going to be equal to this blue triangle. That's going to be 1/2. What's the base going to be? Well, it's just going to be 1.5. Right? Since it's starting at 0, the base is just 1.5. And what's the height going to be? Well, that's equal to this guy. Evaluate this equation at 1.5. So this will be equal to 1.5. Oops. This will be equal to 0.125 times 1.5. In fact, you guys, since I like you guys, I'll put you guys in color. 1.5, 1.5, and 1.5. Good. So x is less than 1.5. This is going to be the base right here. Base. And this is the height. Ah. Good. So then we just multiply that all out and get an answer from there. So we get 1.5 times 0.125. So the height was 0.1875 times 1.5 times 0.5. I get a final answer of 0.1406225. Okay, so let's see, this guy goes there. Okay, so now let's try to find another one. Let's say we want to find the probability that x is less than 3.275. Ugh, ugly numbers. All right, so picture is going to be, okay, I go this way, I go that way. That's a 4. Here is a 3.275 right in there. And I got to go that way. And I got to find the area of this guy. So it means I got to evaluate that. And going over here, I get 0.50. This is P of x. This is x. Okay, so it's the area of this triangle here, this blue one. And so that should be pretty straightforward again. It's going to be 1/2. It's always 1/2. Times the base. Well, the base was just equal to that guy. So it's going to be 3.275. And then the height is going to be equal to evaluating this equation at that point. Since again, this equation here is y equals to 0.125x. So this will be 0.125 times x, which we said was 3.275. Let's erase these guys. 3.275, 3.275. Good, so we can just multiply that out. So we get 0.125 times 3.275 times 0.5, I'm getting 20, I'm getting 0.2047. Any questions? No? No? Okay, so we want to look at a nice pattern, right? Mathematicians love patterns, therefore you should love patterns too. Notice that because we started at 0, it turns out that whatever x value you plug in is always the base, right? Because it's starting at 0 to that point. So whatever stopping point you want right there will be the base. So here we wanted to go to 1.5, so the base was 1.5. Here we wanted to go to 3.275, so the base was 3.275. That's an easy thing. The other thing is the height will come from evaluating our equation at that point. So that is this right here. So why don't we do it in general? Anytime I give you any number, any value in there, you can easily find it by applying this formula. So in general, find the probability that x is less than, we draw it up, what letter we have? Say A, so we have to use A here. Probability that x is less than or equal to A. Well, let's do the picture for it first. Picture is going to look like that. Here's 4. Here is some value A. I don't know where A is, but A is going to be some number between 0 and 4. And so I want to find the area right in there. Right? I know that this guy, just like before, this is 0.50. And I want to find that point, I evaluate it. So just like before, this is going to be equal to 1/2 times the base, and the base is A, times the height, and the height is going to come from evaluating this equation at 125x. So this is going to be equal to 0.125 times A. Good. So in general, I can simplify this by multiplying the A's and multiplying those two. So in general, the probability that x is less than or strictly less than A, or somewhere between A, 0 and A, is going to be equal to 1/2 times 0.125 A squared. And then if I multiply those guys, I'll get 0.0625 A squared. Good? Any questions? Any questions? So what did we just create here? This is a simplified little equation where all you have to do is tell me the value of A. I plug it in there, I do this math, and it automatically gives me the area of the triangle to the left of that point. So it gives us the probability that x will be strictly less than A, from 0 up to A. Does that make sense? Good. So now that we have that nice little shortcut, we can use our calculators to evaluate this or find probabilities for lots of values of A. When A is 1 or 1.2 or 7.5, because it turns out all I have to do is just replace A here. Whatever A value you give me, I'm going to square it and multiply it by this decimal, 0.0625, and it'll automatically give me the result that I'm looking for. Got it? So back to this case, right? Somebody asked you, what is the probability? What's the probability that x is less than 1.5? Yeah, okay, we could do this whole thing here where we find the triangle, find the little thing, or we can just use that formula over there. So we know that the probability that x is less than 1.5 is going to be equal to 0.0625 0.0625 times 1.5 squared. That's going to give me 0.140625. No other work needed. I don't need to come up with triangles and bases and heights. It's just all built into there. Good? It's a nice, powerful little equation. Of course, this is only valid for this case, this situation where this whole thing goes out from 0 to 4, and it's governed by this equation up there. So it's an equation that's only valid in this case, but we can easily use it to solve many, many questions involving this one. Same with this. In order to find the probability that x is strictly less than 3.275, instead of finding the triangle and the base and the height and all that, I can go right here and go, oh, I have my nice easy little equation. So this guy is equal to 0.0625 times a squared, which is 3.275 squared. If I punch that in my calculator, I will get the 0.2047, which is the same answer. Right, so it's the same answer as that one. Okay, yeah, question?
I don't think that's the right answer.
Oh, man.
0.
Well, this one's wrong, you're saying?
Yeah, and I did it both ways. and it-
Okay, so
Yeah.
3.275 times 0.125 times 3.275 times 0.5. Yes, 67?
Mm-hmm.
Sorry. Alright, so back to this guy. This guy is equal to 0.6704, which means that this should also be equal to 6704. Are we all good now? Good? Good? Okay, so now what I want to do is that now that I have this nice easy button, let's make a calculator function that we can punch in this guy into it, and it'll be an easy way to get lots of different results. Okay, so let's go to our calculator. Okay, so we turn on our calculator. We're going to go over where it says y equals, type in y equals, and then type in this equation. So we're going to type in 0.0625 x to the power of 2. Right? Remember, our calculator is not clever enough to let us pick whatever letter we want. Calculators only work with x. So x squared. Type that in there. Okay, next, we need to go where it says table set. Right above the window, it's a little button that says table set. So hit second table set, and make sure that your screen looks like this. We need the independent variable to say ask, and we need the dependent variable to say auto. You're only going to have to do this one time. It'll remember it from this point forward, unless you remove the batteries, and then it'll go back to its default setting. But it should remember this. You shouldn't have to do this every time. So go to independent and make sure it's under ask, and dependent under auto. It's table set, which is right above window. So you need to hit second and then window, and it'll get you to this screen. Okay. Finally, you're going to go over to table, which is right above graph. So hit second table, and then you'll get this, and then whatever numbers you get, just delete. Just start deleting everything, get rid of everything. We're going to start from scratch. Okay, so you should get that, and then hit delete on everything. Now, what this is a little section where it will automatically evaluate the equation at a particular point. So, for instance, going back to the original dimensions of this thing, we have that this is equal to 0.125x. This is 4, and then we have some value a in there. These are x values. We have some p of x values there. And then we have areas to the left of a. I could ask you to fill in a table like this, where we have x values there, and p of x is less than a over there. So for instance, 0, 1, 1.1, 1.7, 2, what are the ones we did? We did 1.5, make a 1.5 in there, 1.5, 2, 2 points, what's the other one we did? We did 3.75, 2.7, 275? 275, 3.8. Okay, so for instance, we saw that for the 1.5, that this answer right in here comes from multiplying 1/2 times 1.5 times 0.125 times 1.5, which is the same thing as evaluating this function 0.0625 times 1.5 squared, and that's exactly what this calculator function will do for us now. So if we just type in 1.5 there, it automatically multiplies it all and gives you 0.14063, right? Which is hopefully what we got. I'm confused. Yeah, 0.623. It's rounding the last bit there. Okay, so this is corresponding to this. Right? We did all this work when we wanted to find the area to the left of 1.5. We found the triangle. We did base times height. So we got that answer. But then we found out that this equation right here makes it easy for us. So we can just punch this in there and get that answer. But now we have this built into our calculator where the x value is this guy, the 1.5. So all we have to do is type in 1.5 in our table, and it gives it to us right there. So for all the other ones, we can just type in these values for x and easily fill out this whole table in no time. Right? So just to repeat the table exactly the way it's written, this is 0, 1, 1.1, 1.5, 2, 2.7, 3.275, 3.8, well, I think, okay, so my old calculator will not let me scroll down after this, I don't think. I think it'll, yeah, I think it'll start erasing the last one, 3.8, yeah. Anyway, 3.275. So there we go. So we can just fill in those values here and get all these probabilities quite easily. So this is equal to the probability that x is less than 0, well that's a 0. Probability that x is less than 1, well that's going to be 0.0625. Probability that x is less than 1.1, well that's just going to be equal to 0.07563. We already got that one. 2 is 0.25. 27 is 0.45563. And this one was 0.67035. And we can just find all the other values we want. Any questions about this table? No? Did everybody get it? Anybody having trouble getting that table? No? 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 Good? Good? Okay, so what I want you to think about is the idea of being able to give, say, someone that doesn't have any algebra background at all, this calculator with this nice easy button, so they don't have to know anything about lines or slopes or y-intercepts. They don't have to know anything about drawing the triangle and all that. All they have to know is conceptually what those buttons are doing, right? So we can go to like, I don't know, a third grader. Third graders have not learned anything about algebra yet, so they don't know about slopes and y-intercepts and whatnot. But we can conceptually tell them about this, right? They don't even have to know about that. All they have to know is this, that probability, the likelihood of something. Okay, I think maybe a little kid might be able to understand the idea of the likelihood something can happen, the chances something can happen. And you can tell them that it's described by this picture. So it's like a cake, and you slice the cake, and the bigger the slice, the more likely it is, the smaller the slice, so we can give them this idea of area. So perhaps we tell them that whatever number you punch in here, like if you want to know the probability that x is between 0 and 1, or 1.1, is equal to this little triangle there, that little slice there. And now, instead of jumping into algebra and finding it and the area and the base and the height, all that, we could say, okay, now go over to your calculator, type in 1.1, and when you get an answer of 0.07563, that's approximately equal to 7.563%. So there's a 7.563% chance that x will land between 0 and 1. So armed with a calculator and this nice easy button, they can answer lots of questions, right? Is that good? Make sense? Good? So we can go up to a third grader and ask them to solve the following. I need some room here. I'm going to erase this part here because I need room. So this one was 0.1406. So I can ask them to do this. Find the probability that x is greater than 2.7 but less than 3.54. Right? I could do that. So this is kind of like an in-between thing. So what I'm going to do, since I have this nice easy button, is I'm going to break this up into the probability that x is strictly less than 3.54 minus the probability that x is strictly less than 2.7. So this is going to be like a big triangle where it lands all the way out there, minus, okay, so this is kind of like here, 3.54, it's everything less than 3.54, and then 2.7 is like maybe over here, and 2.7 is over here. So if I find the area of the big triangle to the left of 3.54, all of it, the blue, and then I subtract off the red one, where the blue one was over there somewhere, then I get just the little region I want, right? Okay, and then these two things are easy buttons on my calculator. So I can type in 3.54 on my calculator, it'll give me the area to the left. I can type in 2.7 on my calculator, it'll give me the area to the left. And so we completely go around all the algebra. They can answer this question without having to know any algebra at all, or without having to do any arithmetic at all, right? So this is like a math question without any of the math. Any of the arithmetic at least, none of the algebra. So this is going to come from typing into my calculator 3.54. Oh, 3.54. 3.54. So I'm getting 0.78323 minus, now I want to subtract the little tip over here. So I just type in 2.7, and I'm getting 0.45563, and so I get 0.78323 minus 0.45563, which is equal to 0.3276. So there we go. The probability that x lands between 2.7 and 3.54 is equal to 0.3276. You got an answer, and you didn't even have to do any arithmetic or any algebra or anything like that. Good? So this is a way that we can make probability accessible to kids before they're exposed to the algebra part of it. Does that make sense? Good? Maybe? Kind of? Sort of? Maybe? Kind of? Okay. So the reason why I went through all this is because we're going to do something similar now. We're going to do probability distributions with curves on them instead of straight lines. And the math is crazy hard, so hard that we're going to have to come up with a way around it. A nice, easy button on your calculator that finds it. So To do it, you really need to do algebra, but I'm sorry, you need to do calculus, but since most of you guys don't have calculus, and this class does not require calculus, we're not going to do the calculus. I'm just going to show you a nice easy button like this. So it's just important for you to know what it's doing and find the picture, the areas, and then you go over to your calculator and you type some stuff in, and it'll give you the answers without having to do all the algebra, or in this case, all the calculus for it. Good? Questions, comments, issues?